Hello and welcome back to Mr. Powers Teaches Algebra. Hope everyone is doing well today. And today, this week, we are going over what rational functions are and how to graph them. So, what is a rational function first and foremost? A rational function is, hold on a second. A rational function is something that looks like this that we have on our screen here. It's a ratio of two polynomial functions. That's what it is. All right. So in this case here, we're looking at a polynomial function where, we're looking at a rational function where the polynomial in the numerator is at in the nth order. It's an nth order, and the polynomial in the denominator is m. Right. So the highest power of x would be m on the denominator. Highest power of x is n in the numerator. Okay. So anyway, there we go. It's a rational function as long as the denominator is not 0. Most definitions are going to include that, and we will assume that as well. And that's it. So first off, let's look at the most basic rational function to get an idea of what these guys do and how they act. Okay? So the first one we want to look at is the graph of, oh, it's weird, f of x equals 1 over x. That is what we have right here. And I got a bunch of points listed out here. And so let's take a look at those. Let's start off with the right and move our way left just to take a look. So we got this 10 and then 0.1, so 1 over 10. So you see it's very small. And of course, as we go, actually, if we started here, 1 comma 1, 1 over 1 is 1. And we go over right, 1 over 2 is a half, 1 over 3 is a third. So you can see as our x's are getting larger, our y's are getting smaller. And at some point, it's going to be 1 over a really, really large number, which is close to 0, right? You can see that here. I can move this over if you wanted to. We could click and, oops, I could put a point on this. There we go. And we could just say, hey, let me see this. And we could slide it over, slide over, slide over. And you can see we're getting closer and closer to 0. But it never really gets there. It will never get to 0. It'll get smaller and smaller and smaller. But it'll never get there. Okay? So that's an interesting thing. Now, oops. Excuse me. All right. So now going the other way from 1 over 1, if we go 1 over a half, so I'm not going to go straight to 0, but a half. Well, 1 over a half is 2. So as x is getting closer to 0, but it's less than 1, our values are getting large really fast. 1 over a fourth is 4. 1 over an eighth. Hello. Oh, it doesn't want to be nice with me on this one. There it is. 1 over an eighth is 8. Okay, and you can see that as we're getting closer and closer to 0, these values are getting huge. 1 over 1/1,000,000th is a million, right? So this graph is shooting up huge. But what's 1 over 0? Well, we can't do that. We cannot do that. Now, I have a table over here, too, where we can see these values we plugged in here. We've taken a look at some of those. But if I type in 0, it's giving me infinity, which maybe sometimes. And there's a reason for that, right? Because 1 over really, really small, if it's not 0, but 0.000, like tons of zeros here, 1, this becomes, it's treating that as a 0, right? So, a little technology thing. Let's see here. Now, we got a huge number, right? Gets huge really fast. So, let's go ahead and take a look at the other side, right? If we start here, -1, -1. 1 over -2 is -1/2. So the same thing is happening, getting closer and closer to the x-axis there. And as we're going from -1 to just to the left of 0, it's also getting huge negative-wise, right? In big negative numbers, or really, really, really small numbers. 1 over an eighth is 8, right? And so on and so forth. So we can see that happening there. All right? And so what are we getting with these? Since we can see that as we're getting closer to 0, from the right, we're getting closer to this line here at y equals, or actually at x equals 0, this purple line. And as our x values are getting larger, we're getting closer to the x-axis, which is y equals 0. Getting closer and closer to this line here. Let's see here. Let's get you a better color. There we go. So we can see that's kind of happening here. Anyway, so we call those lines asymptotes. And so that's the last thing I want to talk about when we're looking at these here, is that, hey, we got these asymptotes happening. Okay, we have this guy right here. I'm sorry, I totally forgot to zoom in on these. That means I'm way zoomed in. Oh my goodness. Oh well, here we go. Okay, so this line here, y equals 0, is in this case a horizontal asymptote. What is a horizontal asymptote? It's a line that our graph is approaching at extreme values, at very, very large values of x or very, very small values of x. We're getting closer and closer to this line. Okay? All right. Now, we also have this line here, this vertical line. That's a vertical asymptote. That's at x equals 0. That guy's x equals 0, and that is our vertical asymptote. Oh, let me see here. Can I write straight? Vertical asymptote. I'll get there eventually. Okay. Yeah, I'm doing it wrong. Okay, anyway, there's our vertical asymptote. And how are we getting that value? Well, that's as we're getting closer and closer. For our x values, they're getting closer and closer to 0, because what really happens at 1 over a very, very small number, well, it blows up, it gets huge. But at the same time, in this case, where we have our line is 1 over x, we actually can't plug in 0. 1 over 0 is undefined. So that's something also to keep in mind. Okay? So here is our definitions. Okay. Let's try this again. There we go. Jeez. Line x equals a is a vertical asymptote if the graph increases or decreases without bound on one or both sides of the line as x moves closer and closer to that value, x equals a. In this case, for us, it was x equals 0. And then we have our horizontal asymptote, and I've explained that here, so you can read that as well. So that is the general gist. That is what the line y equals 1 over x looks like. And that is what I really want to go over with you guys today. And in the next video, we'll take a look at more general rational functions, like this, and talk about, hey, so can we look at these guys and be able to tell where our asymptotes are? Or at least, yeah, Where are these asymptotes? We know where they are now for 1 over x, but what if it's different? What if we got complicated polynomials here? How do we find these horizontal and vertical asymptotes? So stay tuned for that. Till next time, enjoy doing math.